This unit is going to be dealing with our Pythagorean identity, finding angles and equations of lines. Sometimes we'll use our calculator, sometimes we won't. It just kind of depend on the question and whatever we're presented with. But we're going to learn how to apply the main identity of circular functions, which is the Pythagorean identity, finding angles with and without our calculator. So again, knowledge of the unit circle is going to be crucial. And also finding the equations of lines using circular functions. Okay, so for any angle theta, cosine squared theta plus sine squared theta equals 1. That is your Pythagorean identity. It is the main identity. It's also where your other two Pythagorean identities are derived from. Okay, it's basically a squared plus b squared equals c squared. It's just now you're looking inside of your unit circle. Okay, normally A and B would represent your legs of your right triangle, correct? But when you put that triangle inside of your unit circle, now A and B technically correspond to your x and y coordinate points. X on your unit circle is what? I share more than one person, and y on your unit circle is what? It's sine. And so then A squared cosine, B squared sine squared equals 1. Why is it 1 and not some other number? That's the radius of the unit circle. Very good. Now, like I said, this identity can be used to find one trigonometric ratio from another. So it says find the possible exact values of cosine theta, for sine theta is equal to 2/3. So if I know that sine theta is equal to 2/3, I can find cosine theta by using the Pythagorean identity and plugging in. So this becomes cosine squared theta plus 2/3 squared is equal to 1, and then algebraically we solve from there. Do you realize the placement of the squared is in between the sine and the theta, but that doesn't mean that you're only squaring cosine, you're squaring cosine theta together. So essentially it is cosine theta, that quantity squared. Do you understand that? Okay. What's 2/3 squared? 4/9. So I have cosine squared theta plus 4/9 is equal to 1. How do I continue to solve for cosine? Okay. Goes back. This here goes back to old school. How do you subtract the whole number from fraction? Or fraction of the whole number? And same denominator. So 1 turns into 9/9. What is that minus 4/9? 5/9. And then to solve for cosine theta. And we cannot forget that whenever we square root both sides of an equation, it's always exactly. So this becomes plus or minus. Simplify this. What does it become? Root 5/3. Because you can't take the square root of 5. It's not a perfect square. However, 9 is a perfect square. So then you just get 3. Question?
So we are allowed to square just a regular sign to make it sine squared theta.
You're saying square, not square root?
Yes.
Yes. So you can square a sine theta to make it sine squared. The only way you can do that is if it's in an equation and it's equal to something else. You just can't randomly square an expression. It has to be an equation. So like you can't just have sine theta sitting there and you're trying to like simplify to something else and you say, oh, well, I'm just going to square it. There would have to have been an equal sign somewhere, so then that way you can square both sides. Okay. Now, if sine theta is equal to negative 3/4 and theta is in between pi and 3 pi over 2, we're going to find cosine theta and tangent theta giving exact values. Now, that notation of pi less than theta less than 3 pi over 2 lets us know that we're dealing with theta in the what quadrant? Third quadrant. In the third quadrant, sine is and cosine is. And so if sine and cosine are both negative, that means tangent has to be positive, because tangent is the same thing as saying what over what? Y over x, which is sine over cosine. Okay? So then again, we're going to use the Pythagorean identity to find cosine. So cosine squared theta plus a negative 3/4 squared is equal to 1. What is negative 3/4 squared? 9/16. What's cosine squared theta going to be equal to? Well, before you take the square root of 7/16, then you take the square root. So then cosine theta will equal, careful,
Plus or minus.
it is plus or minus, but because we're in the third quadrant, it's going to be a minus square root 7/4. Okay, so be cautious. It is plus or minus, but then of course you use the quadrant to determine whether it's going to be a positive or a negative root 7/4. So now that I know that cosine theta is equal to a negative root 7/4, I can find tangent by plugging into the formula. Negative 3/4 divided by a negative root 7/4. How do I simplify that? So I have to multiply the numerator by the reciprocal of the denominator. My 4's cancel out. My negatives become positive, so I get 3 over the square root of 7. Can I leave it as that? I have to what? Rationalize. So that means I have to multiply the top and the bottom by square root of 7. That becomes 3 square root of 7 over 7. Questions? One of the more trickier ones is this one here. If tangent theta is equal to negative 2 and theta is in between 3 pi over 2 and 2 pi, we have to find sine theta and cosine theta, giving answers exactly. What a lot of students like to do is they like to say, oh, well, tangent is sine over cosine, so that means sine is negative 2 and cosine is 1. No, it doesn't work out that way. You cannot do that, okay? You cannot make that whole number into a fraction and then assign the two trig functions those values. It will be wrong every time, okay? But you do know that tangent is sine theta over cosine theta, correct? So then you can set that equal to negative 2, okay? And then I can multiply both sides by cosine to get cosine out of the denominator. And now I have an expression for sine. Sine theta is equal to negative 2 cosine theta. So I can plug in negative 2 cosine theta into the Pythagorean identity. Okay? And when I do that, I have cosine squared theta plus negative 2 cosine theta squared is equal to 1. I now have an equation where I have one trig expression, not two, that I could solve for the one trig expression. Does that make sense? Now realize when I square negative 2 cosine, what does that give me? Positive 4 cosine squared, very good. A cosine squared plus a 4 cosine squared gives me, how do I solve for cosine? And then, now remember, when I take the square root, I'm going to end up with plus or minus. For what quadrant am I in? And cosine is what in the fourth quadrant? Positive. So I know that my answer is going to be a positive square root 5 over 5. Because this technically becomes 1 over the square root of 5, then I'll have to rationalize, and then that's how I get square root 5 over 5. So cosine is square root 5 over 5. I can take that and plug it back in here because that is what sine was equal to. So this becomes negative 2 times the square root of 5 over 5. So then what is sine theta? So let's apply this. The length of two of the sides of a triangle are 4 centimeters and 5 centimeters. Let theta be the angle between the two given sides. The triangle has an area of 5 square root of 15 over 2 centimeters squared. Show that sine theta equals the square root of 15 over 4. And then find the two possible values for the length of the third side, all non-calculators. So in this one, you had to show that theta was square root of 15 over 4. This is a show problem, which means you need to actually mathematically do the algebraic processes to get to that point. So since you know the area of a triangle is equal to 1/2 your two sides times the sine of your angle, that is what your area formula should actually equal. Okay? So basically you needed to solve for the sine of theta. That could be anything from multiplying both sides by 2. Okay? So then that way it just turns into 4 times 5. Sine of theta equals 5 square root of 15. This becomes 20. When you multiply 4 and 5, you divide both sides by 20. And then sine theta is equal to 5 root 15 over 20, which can be reduced to the square root of 15 over 4. Okay? Now, it says find two possible values for the length of the third side. Well, you have two sides of a triangle. So you have 4 and 5. Okay? Now, if you're trying to find the third side, usually there's an angle involved, right? That you use the formula a squared equals b squared plus c squared minus 2bc cosine that angle, correct? Cosine theta. You know what sine theta is. How can you find cosine theta if you know sine theta? The Pythagorean identity. So cosine squared theta plus the square root of 15 over 4 squared has to equal 1. So then that way you can actually have something to plug in for cosine of theta. What is the square root of 15 over 4 squared? 15 over 16. Because you know when you square root, it goes away. And then 4 squared is 16. How do I keep solving? Subtract. So then that gives me. And then when I take the square root, cosine theta is going to equal. And it did say find the possible values, right? So you need the plus or minus in this particular case. So now that I know that cosine theta is equal to 1/4, I can actually find my third side. So this becomes a squared equal to 4 squared plus 5 squared minus 2 times 4 times 5 times 1/4 or negative 1/4. Because that's what cosine theta is equal to. So then this turns into 4 squared, which is 5 squared, which is, and then 1/4 of 4 is, so technically this is just minus 10. So then that gives me 6 plus 25, which is 31. So then A could potentially be the square root of 31. It wouldn't be negative square root of 31 because what does that represent? What does A represent? And side lengths can't be negative, right? So that's one of your answers. The other one would be if I were to plug in a negative 1/4. The only difference, instead of it being 16 plus 25 minus 10, it would be 16 plus 25 plus 10. Because the negative and the negative would make a positive. So that would give me 26 plus 25, which is 51. So a squared is equal to 51. So then a would be the square root of 51. Because it'd be 5 squared. And then a fourth of 4 is 1. The negative and negative make a positive. All right, so let's talk about a few properties when it comes to finding angles, okay? When we look at the unit circle, okay, the sign or the value of sine in the first and second quadrant are the same. That's why the sine of 180 degrees minus theta is the exact same as the sine of theta. In the first and second quadrant, cosine is positive in the first, negative in the second. That's why when you do cosine 180 minus theta, it equals a negative cosine theta. Cosine has the same sign in the first and fourth quadrant. That's why when you do the cosine of 360 minus theta, it equals the value of cosine theta. And in the first and fourth quadrant, sine is positive, then sine is negative. So when you do sine 360 minus theta, you get negative sine theta. The same applies for radians, so instead of being 180 and 360, it'll be pi and 2 pi. Okay? You use these different type of properties to find the angles for theta in between the different values for ones that are not on your unit circle. So for this, we're going to be using our calculator here. Okay? I'm using our calculator for these examples. So given that, find theta, given that theta has to be between 0 and 360 degrees, such that cosine theta is equal to 1/3. Cosine is positive in which quadrants? First and fourth. So to find the one in the first quadrant is very simple, right? To find an angle, what do we do in our calculator? Second cosine, right? We do the inverse. So we'll do the inverse of cosine. We'll type in 1/3, and before we click enter, we want to make sure that we are in what mode? Degree. And we know it's degree because it says between 0 and 360. So I'm going to check my mode real quick. I am in degree, so I'm good to go. Cosine inverse, 1 divided by 3. And so one of my angles, the angle that's in the first quadrant, is going to be 70.5 because we rounded 3 significant figures. Okay? Now to find the other one, to find the one that's in the fourth quadrant, we're basically going to use this property right here. We're going to do 360 minus theta to find our other angle. Okay? So what is 360 minus the angle that's still sitting in our calculator? $289. So then 289 degrees is the other angle where cosine is equal to 1/3. Because of our knowledge of the unit circle, we want it where cosine is positive, so we know it's going to have to be the one that's the 360 minus theta. Mm-hmm.
So if it's 180 minus theta, would that be negative?
It would have given us negative 1/3. Mm-hmm.
Oh, A, B, and C have to do with each other?
No, they're separate.
Oh.
It's the same directions though for A, B, and C. So let's do B. Okay, let's find the where is sine positive? Which quadrants?
The first and second.
1 and 2, first and second. So then once I figure out what theta is by doing the sine inverse of 3/4, that will give me my first quadrant. Okay? Then I'm going to use the 180 minus theta to find the one in the second quadrant, because like you guys said, sine is positive in the second quadrant as well. So then, what's the first one? When I do sine inverse of 3/4? Say again. 48.6. So that's one angle. To find the second one, I need to subtract that answer from 180. What's the
131.
131? Confirmation? Tangent works the same way. Tangent is positive in which quadrants, though? 1 and 3. Okay, so what's the tangent inverse of 2? 62.4? 63.4. Okay, so tangent is positive in the first quadrant and in the third quadrant, so that means we want to add 180 to this, and so then when I add 180 to that angle that's already sitting in my calculator, what do I get?
243.
So that'd be 240. Simple enough, yes? Make sure we're aware of our signs and our quadrants for where they're positive and they are negative.
For when you're choosing which one of the properties you use, so if cosine theta was negative 1/3, you would use the 180 minus theta for it.
So if this was a negative, cosine's negative in the first quadrant, or is in the second quadrant and in the third quadrant. So then if it were negative, okay, so cosine theta were a negative 1/3. We know that we would do cosine inverse of negative 1/3. Do that in your calculator right now. What do you get? 109. Okay, so you get 109. So you get the angle that is in your second quadrant. Okay, so then to get the one that's in my first quadrant, or that's not my first quadrant, my third quadrant, I'm going to have to do, if I do 180 minus that, that's going to give me a first quadrant angle. You would have to do your 360 minus 109 to get your angle that's in the third quadrant. Okay? If you did 180, you'll get an angle that's not between 180 and 270. You have to give you the one that's going to give you in between 180 and 270. So then you do 360 minus that. Then you get 250. Okay? You guys give these a try. What's the difference between these and these the other ones? They're negative, but also what? You're in radians, which means that you're going to need to change your mode on your calculator to radian. Okay? If anything, you should be able to find at least my first angle. Okay? If you struggle to find the second angle, that's fine. We'll go over it once you guys give it a try yourself. So I'm going to change my mode over to radian. And then I'm going to do the sine inverse of negative 0.4. Okay? So the first angle that it gives me is an angle that's not in between 0 and 2 pi. So how can I get a value that's in between 0 and 2 pi? Add 2 pi. Okay, because that's not wrong. Technically, that's corresponding to the angle in the fourth quadrant heading in the clockwise direction. We want the angle that would be that same spot if we were heading in the counterclockwise direction. So just for a visual, this is technically this angle right here. It corresponds it, okay? But we want the angle that's corresponding to what you get when you're going in the positive direction. So then, yes, we would add 2 pi to this value to get our answer. And when I add 2 pi, did you get this? Did you get what we get? Okay, so 5.87. Okay, this right here lets us know that we have to be within that restriction. Okay, so this takes care of the fourth quadrant, but where else is sine negative? The third quadrant. So how do I get that angle? How do I get that angle? Add what to 180? How can I get that angle there? over 2. The only issue with that is that these points, like, they aren't equally spaced from each other, like a 90 degrees or like a quarter of the way. So, because these 2 points, basically we're trying to figure out what these 2 points are here that correspond to the same sign value. Okay, both of these have the same sign value. They're not equally spaced apart amongst the unit circle like how your pi over 4s are. Okay, those are the only ones that we could actually add pi over 2 to get the next angle. And so in order to find the angle that's in your third quadrant, one way to do it is, since we knew that by subtracting or doing 2 pi minus the first angle we found the corresponding positive angle here in the first quadrant. We could add pi to it to find its corresponding one. That's one way to do it. So this 0.4115 number that's in the first quadrant, if I add pi to it, I'll get the one that's in the third quadrant. So that's 3.55. Which way did you do it?
I took the negative when you first plugged in the inverse of sign,
Mm-hmm.
and I just subtracted pi from or I did pi minus the negative, which is just adding pi to the same number.
And you could also do that. Okay? So then those will be your 2 angles where sine is a negative 0.4. Let's do cosine. Where cosine is negative 2/3. Cosine is negative in which quadrants? 2 and 3. So when I do cosine inverse of negative 2/3, do I get an angle that's in the second quadrant or the third quadrant? Yes or no? When I do the cosine inverse of negative 2/3, do I get an angle that's in the second quadrant or the third quadrant? You get a positive angle, and it's 2.30. Is that bigger than pi over 2?
Yes.
So this one does give me my second quadrant angle. So this one I'm good for, 2.30. So then how do I find the one that's in the third quadrant? What do I need to do? I wouldn't add pi over 2, no, because remember, again, they're not equally spaced apart.
2 pi minus theta.
I would do 2 pi minus theta. 2 pi minus that angle. So then my third quadrant angle would be 3.89. 98, I mean. And what about tangents? When I do tangent, inverse, what happens here? When I do tangent inverse of negative 1/3, I get a negative. Okay, I don't want a negative number. I want the one that corresponds to that same angle in the fourth quadrant, but I want the positive one. So how do I get the positive one? Do what? I can add 2 pi. So let's add 2 pi. I know I'm blocking. I apologize. So 5.96. So theta's 5.96. That gives me the positive one. So then how do I get the one that corresponds to what quadrant? Where else is tangent? So it's there. How do I get this one? Pi minus theta?
Theta
You wanted the other way. Because if you did pi minus theta, you'll end up getting the negative And then you have to add 2 pi again. So then you get 2.82. Making sure you're aware of where your quadrants are positive and negative is going to assist you when you're trying to find your angles in between 0 and 2 pi, 0 and 360, using your calculator. Non-calculator is a lot easier because, like I said, you're pretty much just looking at your unit circle and determining, okay, where do sine and cosine share the same value, okay? All right, then the last bit for today is find the equation of a line when we are given a straight line making an angle of theta with the positive x-axis. Then the gradient of that line is going to be tangent theta. Okay? So we're given a line and then we're told to write the equation of the line. The slope of that line is the tangent of the angle. Okay? So in this particular picture, when we're asked to find the equation of the given line, we don't know 2 points. In order to use the 2 points and go through the slope formula and then, y equals mx plus b. But we are given the angle that that line makes with the x-axis, and it is a pi over 6. So then to find the slope of that line or the gradient of that line, we just do the tangent of that angle. Now, pi over 6 is on your unit circle. What is the ordered pair at pi over 6? Root 3 over 2, 1/2. So when you do the tangent of that, tangent is what over what? Sine over cosine. So that's going to become 1/2 divided by the square root of 3 over 2. Can you guys simplify this real quick, please? So then that way we can get our slope for this, or a gradient for this line. So then that is our gradient. So to write the equation of our line, we do know 1 point. What does that point represent? Your y-intercept. And if we're writing in the form of y equals mx plus c, where m is our gradient and c is our y-intercept, then we have the equation of our line. Square root 3 over 3x plus 1. And there's the equation for our line. So just remember, when you have a line that makes an angle with your x-axis, the tangent of that angle will give you the slope of the line. We can also do it backwards. If we're trying to figure out what the measure of the angle is that the line creates with the x-axis, then we'll just do the opposite. So in this particular case, we're asked to find in radians the measure of theta, okay? And we're told that y equals negative 1/2 x. So remember, your slope is equal to the tangent of your angle, okay? What is our gradient in this problem? Negative 1/2. So we basically have negative 1/2 is equal to the tangent of theta. To find theta, what am I going to do? The inverse of tangent. Now, is 1/2 the tangent of 1/2? Is that a value that's on our unit circle? No, so we're going to have to use our calculator for this one. So where is tangent a negative 1/2? Or what's the inverse of tangent and negative 1/2? We have a negative 0.464, but we just have one issue. It is a negative, and the thing is that when I look here, that angle that we just found was this one right here. We don't want that one. We want the one that comes from 0 going in the counterclockwise direction to create that red angle theta. So how do I find? So add pi. Very good. Because if I add pi, that's going to give me this angle here. So add pi, and what do you get? 2.67. Should be 2.68. So our angle is 2.68 radians. That is what the red theta angle is. Questions on finding the gradients or the equation of the line based off this angle?